Alright, in this video I wanted to give a brief overview of one of the defining characteristics we use when we're discussing animal evolution. And that is the symmetry that animals tend to show. So just as a reminder, we are working off of this evolutionary tree for animals. And in an overview video we put all these phylum names on here. And then we talked about these spots along the tree where certain traits developed that allow us to distinguish phylum within the animal kingdom from one another. So one of those defining characteristics is the difference between bilateral symmetry here on this branch and radial symmetry here on this lower branch. We'll see that radial symmetry is definitive of cnidarians. Bilateral symmetry is observed in these 7 phylum. And then there's one organism, one phylum, the Porifera or the sponges, that doesn't actually have any symmetry. So let's look at what symmetry is, how we define the different kinds of symmetry, so that we can use these terms moving forward. So, what is symmetry? Symmetry is defined as a quality of being made up of exactly similar parts facing each other around an axis. That's the working definition of symmetry. But I think symmetry is best shown in images. And so we're going to think about 3 types of symmetry, and we'll look at images of each kind as we go. So here are the examples of the 3 kinds of symmetry. We will be talking about asymmetry, which is basically a lack of symmetry. Radial symmetry, which I'll describe as sort of symmetry around an axis like a wheel would have. And then bilateral symmetry, where an organism is symmetric in a single plane. So let's think about each kind of symmetry and some examples of organisms that exhibit that kind of symmetry. So we'll start with asymmetry. Again, asymmetry is the lack of symmetry. All right, so we have a definition there, right? A lack of symmetry. In animal evolution, asymmetry is characteristic of the Porifera phylum, which we commonly call sponges. So if we look at a cartoon of a sponge, there's no way we can divide that organism into 2 equal pieces that are mirror images of one another. And it's that trait, not being able to divide it into 2 pieces that are mirror images of one another, that makes it asymmetric. So sponges, again, are the example of animals that exhibit asymmetry. And so here's a photograph of a sponge. Again, it's sort of a random growth pattern. There's no easy way to divide that organism in 2, resulting in 2 mirror image halves. Here's a picture of another sponge. Same thing. There's no way to divide that organism in half, resulting in 2 mirror image halves, and that's asymmetry. All right. So the second kind of symmetry is radial symmetry. All right, so radial symmetry is defined as symmetry around a central axis. So again, I'll think of a wheel. A wheel has an axis that it spins on. And if we draw a line through that central axis, the 2 halves of the wheel will always be mirror images of one another. So that's true for a number of organisms. Here's a cartoon of a sea anemone. A sea anemone is one of the, falls into this phylum of cnidarians. And you can see that there are many ways you can cut the sea anemone in half, resulting in 2 mirror image halves. And so we're showing 3 different planes that you can cut the sea anemone in half through. And again, both sides will be mirror images of one another. So here's another example of radial symmetry. Here's a jellyfish. Jellyfish is also a kind of cnidarian animal. And so we've drawn lines through the jellyfish in several different axes. Each one of those lines divides the jellyfish into 2 halves that are mirror images of one another. So if there are multiple ways to cut an object in half, and result in mirror images, that object is radially symmetric. Another great example, a real-world example of radial symmetry is a pizza. But if you cut a pizza right down the middle, you get two mirror image halves. And that's what radially symmetric animals are like. All right, so the last kind of symmetry is called bilateral symmetry. This is a property where we can divide the organism in half into two mirror image pieces, but there is only one way that you can do that. So when we say that we can divide them on a unique plane, that's saying that there's only one way this can be accomplished. So here, for a goat, we're showing bilateral symmetry. There's only one way we can divide the organism in half, and that's with a plane right down the center, dividing the organism at the nose, right through the body. We get a left side and a right side, and they're mirror images of one another. Lots of animals exhibit this bilateral symmetry, as we saw on the evolutionary tree for animals. Most of the branches come from this bilateral symmetry development. Another example are butterflies. Okay, so here's a butterfly. Again, there's only one way we can divide that butterfly in half to get two mirror image sides. That indicates that the butterfly is bilaterally symmetric. So that's just a brief video going over this trait of symmetry and how we assign that which of the symmetric traits a given organism has by looking at the organism and thinking about how we can divide it up. Again, most animals are bilaterally symmetric. The cnidarians are radially symmetric, and the sponges, or porifera, are asymmetric. All right, so if you have any questions, let me know. I'd be happy to answer them, and we'll talk more in another video soon about more traits around animal evolution.